Okay, welcome back to Better Through Tech. Real quick, before we get started and working on our potentiometers, I wanted to cover this one real fast. I wanted to touch upon this a couple episodes ago, and I completely forgot about it. I wanted to show you that the analog pins on the Arduino can be used for the digital pins as well. So you can also use these as input and output, just the same as you would for any of the pins over here, setting up this exact same setup. So don't be afraid. If you're using a lot of these pins and you need more room, you can use all 5 of these for outputs or inputs. It can be used just the same. And we're not going to build it, but I just want to cover it real quick to show you that it can happen. Again, 100 ohm resistor on this one, a 10K on this one, and here's a little bit of a different code to use that button to turn on and off the LED. This time we have this set up as a Boolean. We defaulted it to false, or its primary step will be false. And as you can tell, I have analog 0 and analog 1 as the setup. If we go back here, you can say analog 0 and analog 1. That's all that it takes to call those pins. It's just to hit the A0 through 5, whichever one you're going to use. Just to get, and then when you get into setup, it's just the same all over again. You can just signify it as an input or an output. Down here, we have it set up as a digital read. So if digital read button is equal to high, then on is equal to not on. So what that does is it's kind of like how the other video we set it up, how state is equal to 1 minus state. It's kind of sort of the same basic idea. It's a Boolean operator, so it makes it true or false. So it'll switch back and forth. And then if on is equal to true, then it'll turn the LED on. If not, it'll turn it off. This is a holding state, so if you hit the button, it'll stay on, and if you hit the button again, it'll stay off. Okay, so with that being done and out of the way, let's get back to the main point of the video, and let's start working on some potentiometers. Okay, so here we go. Here's our project we're going to be looking at right here. This is a potentiometer. It's going to be okay if it doesn't quite look like this. I got a couple that probably won't even fit in the breadboard, and I have a couple that are so small that I'll need a screwdriver to adjust. So whatever you got, it's fine. Just remember that if it can't fit in there, just try to use some alligator clips to get some wires to connect it to, so you can connect it to the breadboard. But all potentiometers are really easy to set up, because the fact that they take a variety of voltages. This is going to have to be an analog. This isn't set up like a button, like a tactile button where it's just on and off. Thus, it can be used as a digital read, because this has a variety of inputs, so it'll return a variety of voltages instead of just on and off. This is going to have to be used as a analog read, which will get sent to one of the analog pins. So we're actually going to use the analog pin for what their core use is for. So what we'll do is we'll start here. The LED, you should know how to set that up. We've gone over that a couple times already. So we got our LED hooked up to pin 3 and then pulled to ground. And then we use 5 volts in ground and pull them around. One of the legs on the potentiometer has to be connected to positive, and one of the legs of the potentiometer has to be connected to ground. The third, which is probably almost always going to be the center pin, otherwise known as the wiper, as you can see here, we are going to grab that and we are going to connect it to A5. And that's what's going to allow us to input the voltages, and then we're going to tell the Arduino how to interpret that, and thus we are going to use it to change the delay. We're going to use milliseconds, so it's not technically delay, but we're going to change the count on the mils to change how fast this is going to blink. We can use it for lots of other things too, but we're just going to keep it simple with this one. Yeah, let's get to it. Okay, so here we go. We got our Arduino IDE open. So let's go ahead and start where we always start at, and let's get our global values put into place here. Our values are variables. And we'll start off with our LED again. I put mine on pin 11. We are going to use the pulse width modulation for this demonstration, so You don't have to use pin 11, but you will need to use one of the pins that has the tilde on it. Then again, if you're not horribly sure what that is, that will be pin 3, 5, 6, 9, 10, or 11. So make sure to use one of those pins. I do believe in my video, I think I have it on pin 3. So if you want to follow that, that's perfectly fine. I used pin 11 just because it's a little more convenient for how I have it set up on my Arduino, on my breadboard. Then we'll go down and we'll use int again. And we're going to call this pot, short for potentiometer. And we are going to list that as capital A and 0 for analog pin 0. Then we are going to come down here and we're going to go int, and we are going to say interval, and we're going to give that a timing of 10. We are also going to put in here an unsigned long, and we're going to call that prev, and we're going to give that a value of 0. And then lastly, we're going to go val, and that's also going to be 0. Then we come down here to setup, and we are going to set up our pins. So pin mode, okay, yeah, so lost myself there for a second, sorry. We're going to go LED, and this is obviously going to be an output, and then we're going to go pin mode again. And this time we are going to go pot, but this one is going to be an input. Again, just like I had mentioned on the Tinkercad, these potentiometers are always going to be an input setup. But the reason why we're going to be using an analog setup instead of a digital is because this has multiple levels of input. It's not just going to be an on or off thing. There's going to be many steps in between on and off. So the Arduinos use a 10-bit analog to digital converter, so that will be a total, if you start from 0, it'll be a total of 1,023 steps between fully off and fully on. We are going to program in a map value, and I'll show you how that's set up. Really clever little piece of programming. It's really cool. You can take one set of values and essentially scale them to another set of values, so that way you can use one set of values to control the other set of values. I like them. They're fun to use. This can actually be used for a number of different things, but we're going to be using it for right now, specifically for this example, is we're going to be using it to play with some LEDs. This specific example, with some minor tweaking, can actually be used to play with servos. If you're into RC toys, the trucks, the off-roaders, the Baja, whatever, what have you. If you're into RC stuff, this code will actually allow you to control a servo from any part of the RC world. It's really cool. If you want to do away with the potentiometer, you can do that as well, and you can automate the whole system through sensors, like motion sensors, and have it control a camera, really. It's limited only to you. It's probably a project we'll pick up later in this series, if not maybe in a different one. But for right now, we're just gonna play with some LEDs just to get familiar with the concepts I'm going to be showing you, so that way you know what to look at and how to handle it. So we're going to do our serial.begin because we want to see what the potentiometer is going to be seeing, so we know how to adjust it, which is really important. Next, we'll come down into our loop, and actually, in fact, you know what? We're going to build this with a function. We're going to build this with two functions, actually. So let's go ahead and skip the loop for the moment being and give ourselves a void, and we're just going to call this blank. We're going to give it an int, and we're going to say, how about pots read? So this is going to be the reading value from the potentiometer. We'll put that in there. We'll come down, and then we are going to count mils, because we want this to be a non-blocking code, right? So mils minus, I'll get rid of that bracket in there. That curve doesn't need to be there. Okay, now we got that fixed. So minus, and we're going to go prev, and is more than or equal to, what do we got here? We have interval, right? So more than or equal to interval. then go ahead and do the following. Val is going to equal, and this is going to be a new keyword command for us. This is going to be analog read, because we're reading in a value, and we're going to be taking that from pot read, from the potentiometer read. And next line down, and this is where the fun's going to happen right here. This is going to be the map value. And once we finish typing this out, I'll explain how this works. But we're going to say map, because that's the next keyword, next key command word, curved brackets. Then we're going to say val again, comma. Make sure you get all these done right. Now, the first commands, the 0 and the 1023, those are going to be the commands from the potentiometer. Make sure not to get these backwards, because then it won't quite work right. So these first two are from the potentiometer. The second two values are going to be outputted as a analog write, and we're going to send those values to an LED, right? So the max value we can send an LED will be 255. And then we get that done. Nope, no, we don't want to do curly brackets. We're going to go down here, and this is where we're going to do our second function. Just like C++, we can do functions within functions. And we're going to go val, because we're going to send that out. And then we will do a serial.print line here, because we want to see what val is sending out. We'll space that, then we'll close this one out. We'll say end of the loop, so we know that's the end. Actually, that's not the loop, is it? That's the blink. So end of blink. And while we're at it, I'll just mark that to that, as well as say end of the loop. And now we'll come down here, and we're going to do our second function. We're going to do void, and we're going to say light. We can't say LED because we already have LED up here, and it will definitely throw us a flag and get mad at us and start highlighting things in red and said we cannot do that. So we're going to have to call a little something different here. So we're going to go light, and we're going to say analog, and we're going to use write, because we're going to be having this LED be multiple levels in between, just on and off. So remember, digital write is just on and off. Analog is everything in between. You can still use it as on and off, but I like to think of it as using it as everything in between. So we're going to mark that with the LED, because that's the LED, pin or name of the pin we're going to be using. And just like how we just set up this function, we're going to be using this input here, and we're going to say input. So, and last but not least, we will close this out just to make sure everything stays consistent. So end of light. So what this reads, actually, you know what? I probably should finish this part real quick, just so I can completely explain what's going on here. The pot. So what this is going to read is, make sure I got this. Yeah, okay. So I want to make sure I had this all broken down right. So what this is going to do is this is going to send the pot value, the input, potentiometer input, right? It's going to send the input value of potentiometer into blink. And I'm rearranging text now. Okay. Just don't drag your mouse like I did. That's anywho. So what it's going to do is then send it down to blink, where we have a internal controlled function here. So then we can rename it. But now that's why I changed it over to pot read. And now you can tell pot read goes into the analog read function, where it gives it the name of val. And val will come down in here to map. And remember, everything gets read from right to left. So it'll read this before it reads all of this. Actually, I should say it will read this before it reads this. That's a little more accurate. So what it'll do is it'll send this to here with these constraints, and then rewrite val as this val. So it's kind of like somewhat of an updater. So you'll send information here with these constraints and send it over here, which then sends it down to here. Sends it to light, where our secondary function will kick in, which then obviously sends it down here, and then thus will control the LED light. I know it looks a little confusing, but this will pay off dividends when we start getting into more complicated code. It'll make huge differences once we get into more complicated code. So let's go ahead and select our Arduino, and let's go ahead and upload, see where we're at, see if I mess this up or if we're good to go here. Nope, all on the first try. Look at that. All right, well, now I'm slacking here. I don't have my camera on. Shame on me. Let's go ahead and get this zeroed in. We'll zoom in, show it, and all right. So we will. Okay, now we got this recording. So now we have this uploaded, and as you can tell, I have my little potentiometer here. This is a 10K pot that I'm using. You don't necessarily have to be using a 10K pot. If you are, you'll have a little bit of a bigger area to control. The bigger the number, for potentiometers, the bigger the number, the bigger the area in between 0 and max value you can play with. So you'll have a little bit of finer control between those two states. I'm going to put my tool in here, and I'll spin it, and you can see spin it really slowly, and the light will start turning on. And the more I continue to spin it, the brighter it gets. So remember the map value. It's going to take that 0 from 1023 and 0 to 255 and map one to the other, adding those constraints. So it's a percentage value of one over the other. So when the potentiometer is reading full output at 1023, the LED should be reading full output at 255, right? So if we open up our serial monitor on this, and there we go, there's our 255. And then as we start rolling back our number, you can see it starting to drop. And as it drops, you can see the LED goes down in brightness or lumens as well. And down, 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 down until we get to 0, and it is off. So, I know this is a little bit of a rather simple oversimplification of how to use this setup, but there's many things we can do with this. And one of the next things I'm actually getting ready to show you right now is one of those things. You'll need a drastically more powerful light to do this, but all the code will still be there just the same. So what we're going to do is we're actually going to make ourselves a strobe light. And we'll use this as a little light as representation. If I can find my big LED light, we'll create the full effect, and we'll get the whole strobe light thing going, right? So what we're going to do, let's see where I'm at. So we need to let's change this, because now we're not going to be using this as output. We're going to be using this as a delay value. So we're going to change it over to 500. Then we're going to change this over to, call that weight. We'll come in here. Let's see. Actually, we're going to be using mils, so we got to put in another unsigned long, and we are going to call it prev light. You want to keep things specific towards what areas they're working on, so that way if you have any issues with anything specific, you know what it is that's causing the problem. Because if you just called this prev 1 and then you called this prev 2, yes, it'll work. But as you start getting into multiple hundreds of lines or multiple thousands of lines of code, they're going to start getting a little rather hard to keep track of and what, where, and why. So practicing a simple naming convention can help out dramatically about what's what. Yes, you can just click on these and wait till you find something that lights up, and you can do that. But giving them the proper name convention will make everything so much easier to track. Anywho, so back to the point here. So we got the prev light. So we're going to come down here, and we're going to go down in here, and we're going to set up ourselves another mil. So mil minus, and we're going to say prev light, right? As more than or equal to the weight. Did it again. And then, oh yeah, that's what I wanted to do. I wanted to get a state put in there as well. So we're going to go int, we're going to go state equals 0, come back down here, and we're going to say state, and then we did this in the last video, right? So state equals 1 minus state, minus that f. And then, once that's done, come back down, and then we're going to do our updater. So prev light equals the mils Then we will close that out. Then we come down here and say if, right, state is equal to high, then we are going to turn this on. Else, and then we don't have to have it. It'll still work with AnalogRead, but I can't let it do that. So we're going to say digital write. And then digital write again, LED, and low. And then we're going to close that out. My apologies, my throat's getting a little dry here. I had to drink me some tea here real quick. Okay. So now what this is going to do, now we've changed this over, is instead of this is reading a output variable, this is going to read delays. And it'll send this out, the light, which then will do the timing again, but instead of sending the value straight out, it's going to flip the state between on and off per the mills that count the flip, right? It reads the updater, and then that updater will keep everything up to date. But as the state turns from true to false, it'll turn this from on and off, and then that's how we're going to get our strobe here. So let's go ahead and upload here, see what we get, and I forgot how to spell again. Need to put the T in there. You'll do this a lot, trust me. You see me making mistakes, and it's maybe kind of funny to see this, but trust me, as you start programming and start venturing out on your own and start doing your own stuff, you will make these same mistakes just as I. You know, watching the TV shows are cool and all. You know, you get those hackers out there just typing a mile a minute, just getting things done and just done. All right. Let's attack them with our code. Yeah, that's so unrealistic. That doesn't ever happen in the real life. With all the people I've worked with, all the professionals I've worked with, all my professors I've worked with, that doesn't ever happen. Even simple codes can take hours to put together. You can have very straightforward ideologies about how you want to put code together, and it can still take you hours. Getting the flow down right, getting the debugging down, and then once you do get it working, then you have to fine-tune it, just like how we have it here. Let's see here. Do we have our... Oh, we're not reading anything at the moment. So, what do we got going on here? We need to... We're reading information, but we're not reading information. So, let's look into what we've got. Val, print line. So, okay, so there's our serial monitor. Serial monitor can help you figure out a lot of stuff. So there we go. So now we know our potentiometer's working because we're getting a reading. So, but our LED light is not doing anything. So we have to look and see what is going on. So we know we're getting a reading, but we're not getting any actual output. Because I gave it an assignment value instead of a comparative value. Yes, that will not throw a flag. So make sure you really pay attention to what you're doing. I'm kind of glad that I have some mess ups on here because you can see first person the kind of stuff that you will end up running into, and thus it'll help you see and expect things. Because you know, I've been doing this, roughly, oh, I don't know, holy cow, I've been doing this for a number of years. I've been doing this for a number of years before I even started college, and I've been doing this for almost 2 decades now, and I'm still doing simple little mess ups like that. But now we get our see, there we go. So now we are getting our reading. So if you look at the serial output, you can see where the potentiometer's sitting at compared to what the LED light is doing. So this is our fine-tuning part of this, right? We have to figure out what's going to be reasonably a good value, and I can tell right now that the camera is only seeing a light glow, but I'm still seeing very much a flicker here. So for all you viewers in YouTube world, we're going to roll this back just a little bit just so we can get that flicker. So we can say back up here on our mapping value that our highest or our fastest value is going to be 22. We don't want it to go any faster than 22, right? And then we can start rolling it back. And we can look at this and keep on rolling it back. We can look at the potentiometer and we can go, okay, I don't think that this will reasonably go, I don't know, any lower than 150. So we can grab that 500, kick that 500 out of there, and we will put 150 in there. Now you have custom tuned your program specifically to what you find it as the most ideal parameters. So what now you have done is you've taken the values between 0 and 500 in that same span of the potentiometer, and now have increased it. So now instead of being between 0 and 500, now it's between 250 or 22 and 150. But you're still covering the same distance in potentiometer. So in essence, you have increased the resolution at which the potentiometer can now function. So now, in that same distance, you can get way more control out of that potentiometer. So there's all the way up, and now we'll start rolling it back, and there is our slowest setting there. So there it is. We have just used our first map value, two functions, one function and a function for that matter, and we have built our first controlled blinking state. Like I said before, this can very easily be converted over to a servo, which we will do here later. Actually, matter of fact, I do want to do that. I want to show you that. It's really easy to use. It's really easy to do. And we might even use that as our example to put in our first library to make it so we can control those. But again, congratulations. We have now finished this. Let's go ahead and move on to our LDR, a light density resistor. And we will control lights dependent on what the surrounding environment it is. So hold tight, let me get that set up, and I'll be right back. Alright, and the last thing we're going to take a look at for this video is called an LDR, or otherwise known as a light density resistor, which is going to be this little guy right here. This little guy right here will, it kind of acts like a variable resistor, but it's dependent on the light output that it can see. So what we're going to do is we are going to set it up so that way it takes in the value of the surrounding light, and we will get it to turn on a light accordingly. A very simple way of looking at this would be kind of like a night light or street lights. A lot of street lights work off of this method. Work store signs. A lot of them will work off this way of operation as well. So that way they can detect whether or not the certain threshold has been hit, and once it has, it'll turn on those lights. That way, you don't have to figure out clock scales year round. You can just get it to just work on this day in and day out every day, since through winter and fall, the amount of hours that are daylight hours that are available changes constantly. So this is a good way to combat that. So let's go ahead and let's start getting our value set up, and we will be looking at setting up an int, because we're going to use an LED for this. Mine's on pin 11 again. And then next we're going to go, we're going to just call this an LDR, light density resistor, keep it short for that. We have ours on the analog pin. Next we will go, actually, matter of fact, you know what, I forgot to show the Tinkercad file. So let's go ahead and finish programming this out real quick, then I'll pull up the file so you can see how everything's wired up. If you remember the LDR, this LDR will be programmed just like the tactile button is. It's set up exactly the same way, but I'll pull the file up just to show you after we're done doing this. So we will go int, and we're going to go LDR read, because this is going to be a hold value, and then we're going to use the define values and say lower value. We're going to say, I already did pre-testing, so I already know, but I'll show you how to check it anyways. But I'm going to say 700 on this one, and this one as well. We're going to go upper and say 701. And we can come down into setup and do our pin modes. Right, LED output, and then we are going to go pin mode. Yeah, pin mood. That would work real well, right? So LDR, and this one is going to be an input, since this is going to be sending information into the Arduino. And then we are going to go serial begin, because we want to see the information that is being sent. There we go. So back to the Arduino, so we know how to make our adjustments. So I'm going to keep this one simple. We're not going to do a bunch of additional functions on top of this. I'm going to keep this one pretty straightforward. I know this video is getting a little long, and I don't want to make it too much longer. So anywho, so we're going to go LDR read, and we're going to go equal and say analog. This is going to be an analog read. And we're going to give it the value of that LDR. And then we're going to come to if LDR read is more than, actually no, so let's start with the lower value first. So we're going to say less than or equal to lower. So we're going to use this value here as this here. So we will be giving it the lower value, and this is going to be a command. So we're going to give it the curly brackets, and we're going to say digital write. Right? So LED is high, and we're going to arrow down, and we're going to say else space if. So this is going to be a multiple. This is going to have multiple commands in it. So LDR read is more than or equal to upper. And again, we're going to do this, and then we're going to say digital write LED low. And then for our catch-all, don't really need to specifically have a catch-all, but it's nice for debugging, so that way if there is any errors, you know what's going on. We're just going to keep this one really simple. We're just going to say serial.println, and we'll just say error out of range. Right? So if anything happens, if it can't read or just can't sense anything, we'll know that it's causing an error. And then the semicolon, close that out. And then we should be at a place where we can play with this. So let's go ahead and upload it. If it'll upload it. I think I might have. Not only did I forget to connect the Arduino, we have some errors on here. Let's see, what do we got? What do we got? What do we got? Whoops. Of course, that would probably help for that. We'll run it one more time, see if that fixes our issue. Close. And yeah, I forgot also how to spell read, apparently. So get that put in there. Okay, now we're reading, so let's go ahead and pull up our serial monitor. So we got it. Actually, it's not going to read anything at the moment. I forgot to do this. So let's go ahead and put a serial read out here, or serial print line. My bad. My apologies. We're going to go serial print line out here, and we need to give it the LDR read, so that way we can see what's going on. You always want to put commands like this outside of the if else if structure, because if you don't, it's only going to read this when one of these conditions are true. So if you only want to read this this condition when it's within, or only read this when it's within that condition, that's the only one it's going to read. because if this condition is true and you have the serial right in here, it's not going to work. So you always want to do these outside of these if you want to get an overall read of every condition possible. And as now you can see, we are getting a read, and it is reading very fast. We are getting roughly about a 940, somewhere in the 945 to 950 something range. But if you put your finger over it, well, you can see it's dropping down into the 600s. You can kind of see the LED flickering a little bit because I already know my values. But your light might not be the light that you're receiving from outside, or your lights and your lamps might not be the same as mine. So you go ahead and adjust an upper and lower limit for this. I adjusted mine, like you can see, 700 for the lower, 701 for the upper. So that means everything below 700 for the lower and everything above 701 for the upper. And that's how it'll work. And so as right now, it's hitting the upper limit, and if you remember, the upper limit means that the light's going to be low, so it's going to be off. But if I turn my light off for my room, you'll notice very quickly that those readings will change and the light will turn on. So there is a fun little night light, I guess, for you, if you want to put it that way, or numerous other things as well. I can't really think of anything horribly off the top of my head. But if you're doing like a weather station, like an outdoor weather station, you need to track brightness for the day, you can actually use this to tag along with it. If you're doing a weather station that's got like it's detecting whether or not it's overcast, this could actually help with that as well. But yeah, I almost completely spaced it. I apologize. I do these lessons right off the top of my head. I don't have anything structured or laid out. This stuff comes out just as fast as I can think about it, and just as fast as I can put it into words and type it out. So I apologize. I know some of these are not horribly well structured, which I'm sure someone will probably say eventually. Thank you for being patient about this. Like I said, all this stuff comes right off the top of my head and straight onto the screen and straight into the mic. So sometimes I forget to do stuff because I don't have like a notepad with key points to hit to go over to make sure that everything gets hit on. But here's the Tinkercad file real quick to show you how to hook it up. Like I had mentioned earlier, it works exactly like the tactile button does. If you're going to follow what I do, I like to pull things low. So just like again, we're going to be using the 10K resistor, which is going to be pulled to ground. You will be pulling in a positive leg, and then in between the resistor and one of the legs, this is not a diode type setup like LEDs are. So it doesn't matter which way you hook these up. There's no wrong way to hook up a light density resistor. You can hook them in either way and they will work. Just make sure that when you hook up the resistor, that the wire that you're using is on the same side of the resistors in between the main leg of the LDR and the main leg of the resistor. So as long as it's in between there, it'll work. It'll work just like the button will, as far as wiring is concerned. But it will read out like the potentiometer will, and it will give you a varying degree. So that's just something to be aware of. Yeah, so back to the episode, and thank you very much. So, but yeah, if you learned anything good about this episode, if it's helped you out, giving you kind of a little additional info on anything, please help me out. I would really appreciate it. Subscribe to my page, give me a thumbs up. If you're really feeling going the extra mile, go ahead and write something in the comments. Tell me if I'm doing a good job. Tell me something that you'd like to see or something that I need to improve on. I can't get better without help, and I'm look forward to it. Again, if there's anything specific you want to see, just write me up. While I'll see if I can make an episode on it, and I'll help you out with some stuff, and we'll get through this. So again, thank you, and I look forward to seeing you in the next episode.